Welcome back to it. It's Maths Master Class with Leo. Today we are doing integration using hyperbolic substitution. It's still part of integration using trigonometric and hyperbolic substitution, but today we're basically dealing with hyperbolic substitution. When we talk about hyperbolics, in this case, these are hyperbolics. There's a hyperbolic sign and this is a hyperbolic cos, right? A hyperbolic sign and a hyperbolic cos. So now, today we are doing integration using this substitution. So today we'll be doing this one, the hyperbolic sign. Integration using the substitution of hyperbolic sign. So if we are given something like this, this is where we're going to apply what you call x is equals to a hyperbolic sign of theta. Right? So remember, when you do this, you'll always say let x is equal to a hyperbolic sign theta, but dx. For me, I want to remove that dx. So what am I going to do? I'm just going to differentiate this so that I can make dx the subject of the formula. Differentiate this so that I can make dx the subject of the formula. Then what I will have here is a cos of theta. Right? What I'll have is a cos of theta, and then I want to make dx the subject of the formula so that I can substitute it back here. So now, what I'll have is dx is equals to d theta multiplied by a cos or hyperbolic cos of theta. Right? Hyperbolic cos of theta. So now, what will I have? I'll say substitute this where here. Then I'll have the integral of 1 over, where does x I substitute this? I'll have a hyperbolic sine theta plus, this is squared, a squared. Right? Not forgetting my square root. Right? Not forgetting my square root. Multiply by what? A cos or hyperbolic cos of theta d theta. Right? Then what I'll have is the integral of 1 over a squared hyperbolic sine squared theta plus a squared multiplied by a hyperbolic cos of d theta. Right? My square root. Then here I'll have the integral of what? A hyperbolic cos of theta multiply d theta over a squared into 1 plus hyperbolic sine theta. Right? Then what I'll have here is the integral of a hyperbolic cos of theta multiply d theta over square root of a squared into, but remember this one, hyperbolic cos squared theta is equals to, hyperbolic cos squared theta is equals to 1 plus hyperbolic sine squared theta. Right? Hyperbolic cos of theta is equals to 1 plus hyperbolic cos that. Now, so in this case, instead of saying that 1 plus hyperbolic sine squared theta, I'll just say theta. Right? That is what I'm going to say. Now, when I have it like that, what will I say? I'll say the integral of a divided by cos hyperbolic cos of theta multiplied by d theta all over this one. The square root of a squared is a. The square root of cos hyperbolic cos squared of theta is cos or hyperbolic cos theta. Right? Then this one and this one are going to cancel. This one and this one are going to cancel. And I'm left with this. Now I need to integrate that. It's like integrating 1. When I integrate 1 in terms of theta, I'm going to have theta plus c. When I integrate 1 in terms of theta, I'm going to have theta plus c. But I know that I have x is equals to a hyperbolic sine of theta. I know that, right? I know that. Now, when I have this, what am I going to do? Now, I have this. I can just say x over a is equals to x over a is equals to hyperbolic sine theta. Then hyperbolic sine inverse of x over a is equals to my theta. Then substitute it back here. I'm going to have hyperbolic sine of x over a plus c. That is my solution. Let me just write it here so that it's visible. Hyperbolic sine of x over a. Okay, before we take a question, that is my solution. Now let's take a question be further simplified into what? Into ln of x plus root x squared plus 4 plus a actually over a. Right? Over a. Remember, our a is supposed to be squared. Now, when you have it like this, let's take a question. They say from 0 to 2 integrate 1 over square root of x squared plus 4. Right? Square root of x squared plus 4. So now, a squared is represented by 4. That is the first thing that you need to know. Therefore, a is equals to 2. Right? A is equals to 2. So now, I can just say ln of what? Ln of x. What is x plus root x squared plus 4? All over, what is a? A is 2. Right? And then I can further simplify it and say, okay, ln of what? Ln of what is x? 2 plus root x 2 squared plus 4 all over 2 minus ln of what? Ln of 0 plus square root of 0 plus 4 over 0. Is it 0? Wait, over 2. So about that. Now, what is my solution? What is my solution? You can just punch your calculator and get your solution here. You can just punch your calculator. Let me just punch mine and get my solution. When I punch it, what am I supposed to get? So, when I punch this one, I'm going to get ln of what? Ln of 2.41 minus, when I punch this one, I'm going to get ln of 1. Then all together they give me 0.881. 0.881. That is my solution. As far as rule number 13, we are done. Thank you for watching. Thank you for subscribing. Please share the content with your friends and don't forget to like. Tango.